When the world's most powerful rocket, the Space Launch System, SLS, launches in 2018, it will carry with it 13 small satellites. Each about the size of a shoebox, the CubeSats will hold experiments that be released by the SLS at different destinations on its way to Mars. Today, NASA has announced what 7 of those CubeSats will look like, and exactly what they hope to achieve. Among them is a huge laser flashlight that will orbit the Moon that will eventually provide scientists with a map of where to find water sources on the lunar surface. In a future mission, we'd have to live off the land, Jitendra Joshi, head of NASA's Advanced Exploration Systems, explained during a press conference today. This map could help find good sites for that. Another CubeSat known as the Near-Earth Asteroid, NEA, Scout will use solar sail propulsion to fly by a small asteroid, taking pictures and making observations. It aims to improve the current understanding of the asteroid environment and yield key information for future astronauts exploring an asteroid. Lunar Flashlight will use a large solar sail, similar to the NEA Scout sail, to reflect sunlight and illuminate the Moon's permanently shadowed craters, and then the science instruments will measure the surface water ice. Meanwhile, BioSentinel will use yeast to detect, measure, and compare the impact of deep space radiation on living organisms over long durations beyond low Earth orbit. This will help scientists understand the effects of the deep space environment on biological systems as we plan to send humans farther into space than ever before. The BioSentinel mission will be the first time living organisms have traveled to deep space in over 40 years, and the spacecraft will operate in the deep space radiation environment throughout its 18-month mission. Another CubeSat called Skyfire will do a flyby of the Moon, collecting data with onboard sensors. SLS first flight, referred to as Exploration Mission 1, M1, provides the rare opportunity for these small experiments to reach deep space. The 13 CubeSats that will fly to deep space as secondary payloads aboard SLS on M1 showcase the intersection of science and technology, and advance our journey to Mars, said NASA Deputy Administrator Dava Newman. In this first flight, SLS will launch the Orion spacecraft to a stable orbit beyond the Moon to demonstrate it works before the first crewed flight. The first configuration of SLS that will fly on M1 is referred to as Block I and will have a minimum 70 metric ton, 77-ton, lift capability and be powered by twin boosters and 4 Rs-25 engines. The CubeSats will be deployed following Orion's separation from the upper stage and once Orion is a safe distance away. Each payload will be ejected with a spring mechanism from dispensers on the Orion stage adapter. Following deployment, the transmitters on the CubeSats will turn on, and ground stations will listen for their beacons to determine the functionality of these small satellites. The SLS is providing an incredible opportunity to conduct science missions and test key technologies beyond low Earth orbit, said Bill Hill, Deputy Associate Administrator for Exploration Systems Development at NASA. This rocket has the unprecedented power to send Orion to deep space plus room to carry 13 small satellites payloads that will advance our knowledge about deep space with minimal cost.